Hello, my name is Veronica from Punkfish Academy and Punkfish Diving. We start to move towards a chapter that a lot of people really hate, and honestly, I don't understand why. Because it's so nice and easy, and it's so nice to be able to get like an estimation in your head if the gas you have is good for the depth where you want to go, or like this estimation of which gas could be smart to use in a depth where you want to go. So things like this, you for sure you can look them up in some tables, but at least having like an idea where to find the correct numbers more or less is something that's very smart to have in your brain. So it's not that difficult. A little bit of math that we want to do today starts with Dalton's diamond. And Dalton's diamond is the one thing you have to remember, because from this you can find all the other information that you want to have about your partial pressure of gases and your fractions and the pressures of different gases. In the next session, we have a look on the MOD, the maximum operating depth. So the depth where a mix that we know will reach the PO2, the partial pressure of oxygen of 1.4 bar, where we usually set our limit. In the next video, we talk about how to find the best mix. So when we want to go to a specific depth, find out which nitrox to ask for in our filling center. And one more will be the EAD, the equivalent air depth, where we talk about how to compare our nitrox mix with air. So let's get directly into Dalton's diamond. When we look at the manuals, like the SSI manual or take any other manuals, honestly, they are not very much better. You find a big amount of formulas that look chaotic and they look difficult. So if you take them and you just have a look on them step by step, you will see that they are not that complicated. So for example, they just put like depth divided by 10 plus 1, which looks very big and is nothing else than P, the pressure, the absolute pressure where we are. And they put the formula about how to find the absolute pressure from meters into this formula, and that makes it look so chaotic. So what we're going to do is we simplify all these formulas, and you will see that at the end of the day, it's really, really simple and easy. There is just like this one concept you have to understand. And if you remember this concept, you're able to develop the Dalton's diamond formula from scratch every time you need it again. Because honestly, I do not remember any formula of this. I can't. They don't stick to my brain, but I can remember very easily concepts. So I do understand Dalton's law. Dalton's law is this about the partial pressures. Like when we have a mix with two different gases, and each of these gases has a certain fracture or a certain pressure, both partial pressures together will build the total pressure of all gases together. Easy like that. And when the total pressure for this same mix doubles, the partial pressure of each gas will double as well. So for our gas pressure, that means if we want to know which pressure a gas has at a certain depth, we need to know the fraction of this gas in our breathing gas and the pressure where we are. It's like we all know at 1 bar at the surface, we have 0.21 bar of oxygen and 0 0.79 bar of nitrogen. When we descend to 10 meters, where we have 2 bar, both of these numbers will just double. It's 2 times this fraction. If we go to 20 meters, 3 bar, it will be 3 times this fraction. It's always a direct relation between the absolute pressure and the fraction of the gas. And this relation is that the fraction of the gas times the absolute pressure on this gas gives us the pressure of this specific gas. Easy like that, right? And if we have this, we can arrange it in this nice little diamond where like this line means you divide, and this means you multiply, and you can just put the one thing to one side that you need to calculate. So you can just split this diamond up wherever you need to split it up to find the numbers you will want to find, or to find the information that you want to find. And we have a look on this in the next chapters, how we use this and how you do this. But as long as you remember this concept, that the pressure of a gas is always the result of the fraction of this gas and the total pressure, it will all be very easy, promised. Now, if you think now that this looks quite easy, but you're struggling a little bit to understand the symbols and to understand how to get from pressure to a depth, for example, we will explain this as well. If you know this, if this is all clear for you, you can stop this video here, but the rest is for all those who maybe forgot one or two things in between their open water course and now. So the absolute pressure, as you know, is the pressure from the atmosphere, which is 1 bar at sea level, and the pressure of the water we are in. This water pressure is 1 bar every 10 meters. More or less. It's a little bit more, a little bit less, depending on the salinity of the water. But with 1 bar per 10 meter, we are absolutely fine for calculations. If we know the pressure and we want to understand which depth is meant, like at which depth do we reach a certain pressure, then we have to do 2 steps to get from the absolute pressure to our depth in meters. The first is that when we have our absolute pressure and we just want to know the pressure of the water column, and depth is obviously just the pressure of the water column, we have to subtract the atmosphere. So we subtract 1 bar from our absolute pressure, and this gives us the water pressure, only the water column on top of us. So once we know our water pressure, the only thing we have to do is multiply this with 10. Why? Because it's every 10 meter 1 bar. 1 bar is 10 meter, 2 bar is 20 meter, 2.3 bar is 23 meter, 3.8 bar is 38 meters. Easy like that. Next thing we have to find is Fg, the fraction of the gas. This is the part of the specific gas that we want to calculate with in our nitrox course. This will be most of the time oxygen, and the fraction is given as a fraction of 1. So when we have 32% of oxygen in our mix, or let's say we have a nitrox 32 and EAN 32, the fraction of this is 0.32. For a nitrox 36, this 36%, it would be 0.36. For 40%, 0.4. It's all just different names for exactly the same content of oxygen. And then last thing, Pg, the pressure of a specific gas. Now, for our nitrox calculations, in most cases, this will be a number that we set, and we set our oxygen limit, and we set here the 1.4 bar that we want to reach as a maximum pressure that we accept when diving with nitrox because of the oxygen toxicity. There are other videos about this, and you should know about this by now already. Sometimes, for sure, we want to compare partial pressures of other gases for some reasons, and then this will be other numbers, but most of the time we set this number because we just put our limit in here. So I hope I got you a little bit less confused than before, and we will start in the next videos to get into some real calculations for our nitrox dives.